Hello and welcome to SudoKanard. We're here to solve this arrow Sudoku by British author Calum. I think it's the first puzzle by Calum that I solve on the channel. So arrow Sudoku is this pretty common variant where a number in a circle is the sum of all digits along the arrow. And here we have two digits totals, so they are read from left to right. So you could imagine this to be 12. No, actually, that would probably not work. But let's say you could imagine this being 21 with, let's say, 3, 4, 5, 6, and 3. That would work. Well, so this is the rule, and Calum posted this on Puzzle Expo on Logic Masters India. And when I first saw the puzzle, I just thought, no, I can't do this. And then I came back to the puzzle afterwards, and I found that there was a really, really nice and neat logical path. So where do we start? I think we can find the leading digit. We can find restrictions on leading digits. For example, here we sum 7 digits. The minimum value for 7 digits is 28. Yes, digits from 1 to 7, they sum to 28. And the maximum value is 42 if we sum all digits except 1 and 2. So the leading digit is 2, 3, or 4. In this case, those 3 digits, well, this will be at least 12, so we have, and just because I can't put a 0 here as a leading digit, there's no leading 0, and the maximum value will be with, let's say, 7, 8, 9, that's 24, plus 7, that would be 31. So the leading digit could be a 2 or a 3. Here that's a maximum of 30, so maximum of 39. So the leading digit won't be more than 3. This could potentially be 1 or 2, I'm not sure. That one would work. Oh yes, 19 could work, probably. And here, so 3 digits, well, that's always at least a 1, and the maximum value would be 24 plus 17, that would be 41. So this could be as high as 4. All right, so where do you go from here? Here we have 5 different digits summing to this plus that. And this plus that is at most 17. So this is at most 17, plus this, those digits are at most summed to at most 21, and 21 is also the minimum value of the sum of all these, which means that 21 is simultaneously the minimum value and the maximum value for the sum of all 6 digits. So those digits sum to 21, and 21 could only be achieved with 17 plus 4. So that's a 4. Those sum to 17, so that those are 8 and 9. So this is a really some beautiful logic. And those are digits 1, 2, 3, 5, 6. So this 8 or 9 goes there. And those are 7, 8, and 9. And I don't think that it's a good idea to pencil mark all of this. Now we are in the 40s here. So I said if we avoid 1 and 2, then this is 42. So it could be 42 like this. But it could also be 41 with a 3 there. So this has to be 1 or 2. If this is 1, then this is 3. And if this is 2, then this is 1. And 1 is in one of those, so that's not the 1. And we get 1, 2, and 3 here, so that this is also 4. And I say that 41 was achieved by taking the maximum values here, and 41 is here, the minimum value as well. So we get 8 and 9 in here, 7 there, 8 and 9. So a standard min-max logic, perhaps not that standard considering that we're facing here a variant of arrow that is not so common. Now this digit will appear somewhere there, and I'm saying that if I try to put a 1 in here, then 1 goes there together with a digit that is 7 or 8, and none of them is available. So the digit here that is repeated here must be the 3, together with 5 or 6, and we have the 1 and the 2 here. So 3 goes there, that's a 2, that's a 1, and those do sum to 41, indeed. And then this here is the sum of at least 3 digits. The minimum value is 6, and the maximum value is 7. Which means that those are either 1, 2, 3 or 1, 2, 4. So this is 2 or 3. This is 1, 2 or 4. And an interesting point is that 3 on this row will be here. So this is also from 1, 2, and 4. So what comes next? Well, we have 1 and 2 in here, so that this is actually 4. And so the sum is finally 7 with 1 and 2 here, which means that this up there is a 3. And 3 on this central row goes there. We got a 3 somewhere here. Those are 5 and 6. And we still don't know about this. All right. What about this? Not sure that's the right place to look. Perhaps about this. Here in this column, the maximum value here would appear to be 5 and 6, except, I'm saying that 1, 2, and 4, actually, this digit and this digit are not here, so they must be there. 5 and 6 go there. So those digits are from 1, 2, and 4. Which is interesting because we must go as high as 30 something. Here we have a maximum of 6. So those 3 digits must sum to at least 25, which can be achieved with the maximum value, which would be 9, 7 here. We can't use both 9 and 8, and 9 here. So the maximum value of 31, well, the 31 is the minimum value for the sum, but it's also the maximum value we can achieve by putting digits, by putting the highest possible digits into those cells. So that this is indeed 31, and this is 8, so that's 3 and 5. 6 goes there, that's a 5, and here we have 1, 2, and 6. So now, and that's a 9, and that's also a 9, and those are not 9s. Down there I get 1 and 3, so that's the 3, that's the 1. This now can't be a 2. It has to be a 5 or a 6, so that this is 2 or 3 accordingly. The 2 must be here, and this is also 5 or 6. Here I get 5 and 6. And the column still needs a 4. 8 and 9 here go down there. 4 goes here. This is 5 or 6. 2 and 3 are not here, so this is 5 or 6. This can only be 7 or 8. And those are 2 and 4. Those are from 7, 8, 9, and this is not 7. All right. Well, where am I looking next? There is a 9 somewhere here. Could this be 29? Well, the maximum value here, actually, what I must ask is what the maximum value is in here. So here the maximum value would be with 5, 6, and 8, that's 19. And the maximum value here would be a 7. So the maximum value would be 26. Except that 5 and 6 are not available. 1 is not available, so this is 3 or 4, and 9 goes there, which turns this into an 8. That's a 7, that's a 9, that's 7, 9 here, 7 there, 8, 9, that's 8. Nice, really beautiful logic. This is 8, this is 9, and there is an 8 somewhere in here. Those are from 5, 6, and 8. So I'm still making progress, but it's not over. There's still some work to do. This column has the 7 on this position. The 1 is here. And I don't know where 1 goes on this row. This is from 1, 3, and 7, but actually 1 wouldn't work. As I mentioned earlier, the sum here is at most 19, so with the 1 here it wouldn't work. And actually only 7 works. 19 plus 3, that would be 22 maximum, so only 7 works, which means that the sum here is either 16 or 17. Still not over. Those are from 1, 3, and 4. Perhaps this will be the final disambiguator. What could this be? Well, definitely not. Definitely at least a 3. 3 with 1 and 2, that would appear to work. I'm not sure about this. Actually, we can know approximately the sum of those three digits. I said that this had to be either 16 or 17. This is 17. So here we have either 33 or 34, so that this is either 33 or 34, so either 12 or 11. So those can't be too high. It's not easy. So either 12 or 11. I think that 8 here will never work. No, that can't be 12 or 11. So 8 is definitely in there. This would, oh, by the way, that's an 8, that's a 9. 8 is not in there, so 8 in this box is here. This is 7, that is 8. It puts an 8 down there. And on this column, 4 here would never work. It would need this, and it would require those to be 1 and 3, and there would be no choice for this cell. So 4 in the column is necessary here, which means that this is a 3, this is a 1. And the only possibility here is to have a 2 here and a 6 there to satisfy this. 6 is both the maximum and the minimum, so that's the 4, that's a 2. That's not a 6. Here we need a 3 and a 5. So this is 5, this is 8, 16, 23, that works. That's a 6, that's a 4, 2 and 4, 6 and 5, that's a 6, that's a 5, that's a 2, it works, yes. So this is 5, this is 6, 5 and 6, that's a 3, that's a 5, here this is 1, this is 2, and this is 5. And now this column still needs a 2. Here we need a 3 and a 6. Here we need a 1 and a 6. So that's 1, that's 6, that's 3, that's 6. And this is 3, and this is 4. And I just think that this is correct. Oh, I must have the solution in another window. Yes, this is definitely, as said in the famous meme, they are the same picture. So it was not an easy puzzle by any means, but it definitely had a clear solving path, and a beautiful solving path, if you ask me, with really, really nice arguments about minimum and maximum. So thanks for watching this video, and see you soon on SudoKanard.